Okay, this is another paper, the latest paper. Look at this. I have already solved for you. This is February, March 2022. So we move to question number 1. Look at the question. A sphere of a radius 2.1 millimeter falls with terminal velocity, constant velocity to a liquid as shown in the figure. Look at this sphere. It is in the liquid, which has density rho. It has weight 7.2 10 power minus 4. Its radius 2.1 millimeter, and it's moving down with the constant velocity. 3 forces act on the moving sphere. The weight of the sphere is 7.2 10 power minus 4. And the upthrust acting on it is 4.8 10 power minus 4. The viscous force Fv acting on the sphere is given by Fv is equal to KRV, where R is the radius, V is the velocity, and the K is the constant. And the value of the K in SI units is given 17. So it's already done for you. Now, the question is determine the SI base unit of K. So look, this is the equation, this one. We will make this K as a subject of equation. It is F divided by RV. F is the force. It is measured in kilogram meter second power minus 2. Radius is measured in meter, and the speed measured in meter per second. So this meter cancelled. So we have kilogram meter power minus 1. This one is minus 1, second power, this minus 2, and this minus comes up to the positive sign. So the final answer becomes kilogram meter power minus 1, second power minus 1. So this is the final answer for the SI base unit of K. Now move to the next question. Use the value of the upthrust acting on the sphere to calculate the density. Look, upthrust U is equal to rho GV, where V is the volume, and the volume is area into height. R for the sphere, it is 4 by 3 pi r cube. So the density, rho, G acceleration due to gravity for the sphere, the volume is 4 by 3 pi r cube. Upthrust value is given here, 4.8 10 power minus 4. And density required, G value 9.81, 4 by 3, pi value 2 by 3, and the radius is given 2.1 millimeter. So look at this 2.1 millimeter here. So we have to convert this into meter. So into 10 power minus 3 and then cube. So the rho is equal to 4.8 10 power minus 4 divided by 9.81, 4 by 3, pi by 2, and this radius power cube. So the final answer is 1300. So this is the second part. Next. On the sphere, draw 3 arrows to show the direction of the weight W, upthrust U, and the viscous drag F. Label the arrow U, V, and F respectively. Determine the magnitude of the terminal velocity. So look, when the velocity is constant, weight is acting down, upthrust always act up, weight acts down, but this drag force opposes the motion. For the downward motion, it is acting up. So the weight down, upthrust up, this drag force up, and this is the equation because the resultant force is 0. So the sum of the upward forces is equal to the weight. That's why the velocity is constant. So do remember, this drag force is smaller than the weight, and the thrust is smaller than the drag force because this upthrust is rho GV, small volume, small density of this. So in order, weight is greater than the drag force and the drag force greater than the upthrust when magnitude is required to be compared. So do remember, weight is always greater than thrust and the drag force, but the drag force is greater than the upthrust. Now move to the next part. Determine the magnitude of the terminal velocity, mean the constant velocity. So this is the equation we have discussed. So weight is equal to upthrust plus drag force formula is given KRV. Weight is given, upthrust is given, K value is given 17, radius in meter this, and this is the speed. So after calculation, look at this calculation. The answer is coming 6.7, 10 power minus 3. Next, question number 2. Water leaves the end of the house pipe at the point P with a horizontal velocity of 6.6 meter per second as shown in the figure. The point P is at the height h above the ground. The water hits the ground at the point Q. The horizontal distance from P to Q is 3.5. Air resistance negligible. Yes, this is important information. Assuming that the water between P and Q consists of the non-interacting droplets of the water and mean there is no chemical reaction, and that the only forces acting on each droplet is its weight. Explain briefly why the horizontal component of the velocity of the droplet of the water remains constant as it moves from P to Q. Look, air resistance negligible. So in the absence of the air resistance, no force is acting on the object horizontally. So when there is no force, then it's no acceleration. Then there is no change in velocity. So the velocity is constant. Next, show that the time taken for the droplet of the water to move from P to Q is 0.53. Look, horizontal velocity is constant. So the distance is velocity times t. Time is distance divided by speed because there is no acceleration. Horizontal distance is given 3.5. And the velocity is given here 6.6. This horizontal velocity is 6.6. So the answer is coming 0.53. So next, we have to calculate the height, the vertical height, vertical distance. S is equal to ut plus half at square. So for the vertical motion, look at this here. Vertically, there is no velocity. So the initial vertical velocity is 0. Then height is equal to u, t is 0, 1 by 2. Vertical acceleration is 9.81. And the time taken by the projectile in the trajectory is exactly equal to its free fall. I mean the straight height and this projectile, this height for the free fall, and this projectile will take the same time, but in the absence of air. So we will use 0.53 square. After calculation, the answer is coming 1.4. Now the next, for the movement of the droplet of the water from P to Q, state and explain whether the displacement of the droplet is less, more than, or same as the distance along the path. Look, the water is moving like this. It's taking the projectile. It has no fixed direction. Its direction is changing. But this is the shortest distance. This is the displacement. So this is always smaller than this trajectory. The displacement is a vector quantity. It is in the fixed direction. Thus, the displacement is smaller than the trajectory from P to Q. Next, calculate the magnitude of the displacement. Look, vertical height is calculated 1.4 in the previous part, and the horizontal distance is given 3.5. So this is the displacement. So this is right angle triangle. Perpendicular square plus base square is equal to hypotenuse square. So 1.4 square plus 3.5 square under root is this hypotenuse. So which is 3.8. Move to the next question. A jet of the water hits a vertical wall at the right angle as shown. The horizontal jet of the water density 1.0 10 power 3 and the cross-sectional area velocity is given. The water hits the vertical wall with the velocity, this is given. Then the cross-sectional area is given, the density is given. The water runs down the wall after hitting time, meaning there is no Rebound velocity, it's not moving back. So it is falling vertically down. So it means if this is initial velocity, then in the same direction, the velocity final will be zero because water is not bouncing back from the wall. It is going down. So show that over a time of 1.6, the mass of the water hitting the wall is 1.2. So due to the constant velocity, distance covered at the height gained speed into time. But it's better to write the distance, horizontal velocity multiplied by time taken is 1.6. It's given here. So the distance horizontal covered is 5 times 1.6. Mass is density multiplied by volume. Density given, and the volume is area into distance, area into height. So after calculation, it is 1.2 kilogram. Next, calculate the decrease in the horizontal momentum of the mass of the water due to hitting. Look, we have already discussed that the final velocity is zero because the water is not bouncing back. So change of momentum, mass, change of velocity. The final velocity is zero, initial is 5. So mass is 1.2 times is 5. This is 6 or 6.0 Newton second. Then the magnitude of the horizontal force exerted. So Newton's second law, F is equal to change of momentum divided by time. Change of momentum is 6, time is 1.6. So answer is 3.75. We can write it 3.8 into two significant figures. Next, state and explain the magnitude of the horizontal force exerted on the wall by the water. So the water is exerting force on the wall as an action. So there will be reaction. So according to Newton's third law, action and reaction both are equal in magnitude, opposite in direction. Thus the force exerted on the wall by the water is 3.8, the same value. Both forces will be equal. Calculate the pressure exerted on the wall by the water, pressure force divided by area, 3.8 force, and the area is already given here. Look at the question. 1.5 10 power minus 4. So 2.5 10 power minus 4 is the answer. This is the area 1.5 10 power minus 4. After calculation, this is the answer. Okay, so today in the class, I recorded this for you, just to save your time. Now move to this question number 4. A child moves down a long slide as shown in the figure. The child moves from the rest at the top end X of the slide. An average resistive force 76 Newton opposes the motion of the child as it moves to the lower end Y of the slide. Kinetic energy of the child at Y, this point here, is given 300. The decrease in the gravitational potential energy from X to Y mean this one, this. Due to this vertical height is 3200. Determine the ratio kinetic energy of the child at the Y when the resistive force is 300. So it's given 300. This kinetic energy, look, here it's given. And the kinetic energy of the child at Y, as there is no resistive force, then definitely if there is no loss of the energy, then the gravitational potential energy at the X will be exactly equal to the kinetic energy at the Y. So 3200. Due to loss of energy, this is the 300 at Y. But if there is no loss, whole of the potential energy, gravitational potential energy at X will be converted into the kinetic energy at the Y. So 300 divided by 3200. After calculation, the answer will be 0.094. Next, use the speed answer and A to calculate the ratio. Speed at Y divided by speed when the resistive force 76 and the speed of the child at the Y when there is no resistive force. Look, kinetic energy is equal to 1 by 2 mv square. When this portion is constant, then energy kinetic directly proportional to v square, our v speed is directly proportional to under root of the energy. So this speed, suppose v1, this speed v2. So it is equal to energy 1 over energy 2 under root. So the under root of 300 divided by 3200. So when you will calculate this, you will get the answer 0.31. Next, calculate the length of the side from the x to y. Look, the total energy, potential energy at the x is converted into kinetic energy at the y plus some work is done against friction. Mean the kinetic energy gained by the child and the work done against friction, the sum is total potential energy at the top. This is 3200. This kinetic energy gain actually 300. Work is FD and the resistive force is 7600. So 3200 minus 300, 2900 divided by 76. This is coming 38.2. So we can write it 38 meters. So this is the length of the slide. Next, at the end, Y of the slide, the child is brought to rest by a board. Okay, at the end of the slide by, the child is brought to rest by a board. A spring connects the board to a fixed point. The spring obeys the Hooke's law and has a spring constant 63 Newton per meter. The child hits the board so that it moves to the right and compresses the spring. The speed of the child becomes 0 when the elastic potential energy has increased to its maximum value of 140. Calculate the maximum compression of the spring. Look, elastic potential energy is equal to 1 by 2 ke square. Elastic potential energy is 140. 1 by 2. Spring constant is 63. And then E square. So E is equal to 140 times 2 divided by 60 under root. So the answer is coming 2.1 meter. So this is the maximum compression in the spring. Next, calculate the percentage efficiency of the transfer of the kinetic energy of the child to the elastic potential energy. So efficiency, elastic potential energy divided by kinetic energy into 100. Because the in percentage required. So elastic potential energy is 140. And the kinetic energy at y of the child is 300. So 140 divided by 300 divided by 100, multiply by 100. So the answer is 46.7 or 47. Next, the maximum compression of the spring is x naught. Figure 4.3 sketches the graph to show the variation of the elastic potential energy of the spring with the compression x0 to x naught, the maximum. Numerical values are not required. Look, this is the equation. But we have to plot x at the x-axis. So this half kx square can be written as kx by 2 into x. It means this is required at the x-axis. This is required at the y-axis. So this kx by 2 is the gradient. Now, k by 2 of this portion is constant, but this compression is increasing. So definitely the gradient is, this compression is increasing. Look at this, it's increasing. So definitely the gradient will be increasing. So we will draw here the graph starting from the 0 with the with the increasing gradient, and we will finish the question. So I repeat this. Energy is equal to 1 by 2 kx square. Energy is equal to 1 by 2 k x times x. So one of the x is plotted at the x-axis, and the remaining, the other one is kx divided by 2 becomes the gradient of this expression when the graph is plotted between E and x. So k constant, 2 constant, x, this compression is increasing, hence the gradient increasing. So we have to draw here increasing gradient line, increasing gradient. Next, question number 5. State the conditions required for the formation of the stationary wave. It must be of same type. So both waves must be of same type, same frequency, same speed, traveling in the opposite direction, and must overlap each other for the formation of the stationary wave. State the phase difference between any two vibrating particle in a stationary wave between two adjacent nodes. Suppose this is node, this is node. Between two nodes, all particles are moving in same direction. So that's why their phase difference is zero, because all are moving together in one direction. But remember, this is anti-node. Its displacement is maximum. Here, the displacement is minimum. So from node to anti-node, the displacement gradually increases, but all are moving in one direction. Next, a motorcycle is traveling at 13 meters per second along a straight road. The rider of the motorcycle sees a pedestrian standing in the road directly ahead and operates a horn to emit a warning sound. The pedestrian hears a warning sound from the horn at the frequency of 543. This is the observed frequency. The speed of the sound is 334. Calculate the frequency to three significant figure of the sound emitted. Look. The rider sees the pedestrian go directly ahead and operates the horn. So look at this formula. Actually, motorbike is approaching towards the observer. That's why you will write F naught is equal to Bf over V minus Vf. Observed frequency is 540. Speed of the sound is 334. Frequency actually required 334 minus speed of a motorbike 13. After calculation and three significant figure, it is 522. Next, the motorcycle rider passes the stationary pedestrian and then moves directly away. So this is the formula. When the source is moving away from the observer, Vf divided by V plus Vs. As the rider moves away, he operates the horn again. Second time, the pedestrian now hears a sound that is increasing in frequency. Frequency is increasing. State the vibration, if any, in the speed of the motorcycle when the rider operates this. Look, this V is constant, this frequency is constant. It means this observed frequency is increasing, so this must be decreasing, because this F naught is inversely proportional to V plus Vs. Thus, for this reason, this Vs must be decreasing. So the speed of the motorbike must be decreasing. When this Vs becomes small, this denominator becomes small, and the whole fraction becomes large. That's why the large frequency is heard by the observer. Next. A beam of the vertically polarized monochromatic light is incident normally on the polarizing filter as shown in the figure. So this is vertically polarized. So it is just moving up and down. The filter is positioned with its transmission axis at the angle of 20 degrees to the vertical. The incident light of the intensity I naught and the transmitted is IT. By considering the ratio IT over I naught, calculate the ratio amplitude of the transmitted divided by amplitude of the incident. Look, this incident wave has amplitude A, and this transmitted has AX, this direction, X component, A cos theta, intensity directly proportional to amplitude square. So the intensity ratio will be AX over A square, mean AX square divided by A square. AX is equal to A cos theta divided by A cancelled, cos 20 square. So the answer is coming 0.88, or you can write 0.90. Now, next, the filter is now rotated about the direction of the light beam from its starting position shown in the figure. The direction of the rotation is such that the angle of the transmission axis to the vertical initially increases. Calculate the minimum angle to which the filter must be rotated so that intensity of the transmitted light returns to the value that it had when a filter was its starting position. So here it's written such that transmission angle increases. So when transmission angle increases, it means it is rotated in this direction, 20, 30, 40, in this direction. So look at this. When angle is 20 degree, then from the horizontal axis, this angle is 70. Now in the first quadrant and the fourth quadrant of the graph, cos is positive. Here, first and fourth, the value of the cos will remain positive. Now, from the mathematics, it is very clear that a cos 70 as cos 90 and cos 290, cos 290 has the same value. So here, if the angle is calculated, is measured from this axis, so it's 70. Now, when we will rotate it like this, 290. So we will get here the same value of the amplitude. So it means we have to rotate in this direction because we have to increase this angle. So it means this is 70, this is 70, so 70 plus 70 means we have to rotate it by 140-degree clockwise to get the same intensity ratio or the same intensity. Next. The ends of the metal resistor wire are connected to the battery of EMF 8 volt and the negligible internal resistance is shown. The power dissipated by the resistance wire is 36. Calculate the current. Very simple. Power is equal to VI, power 36, voltage is 8, current required is 4.5. Then the number of the free electrons in 50 seconds. Look, I is equal to, current is equal to charge divided by time. But the charges are due to the number of electrons. So the charge is equal to the number of electron multiplied by charge of one electron. So we can replace this Q with NE. So I is equal to Q divided by T. So N is equal to I times T over E. Current given 4.5, time given 50, and the charge of the electron is 1.6 10 to the power minus 19. So we will get this answer. Number of the free electrons. Next, the resistance of the wire, simple again, power is equal to V square over R, and R is equal to V square over power. Voltage supplied, EMF supplied, 8 square, and the power 36. So 8 square divided by 36, answer is coming 128. The metal of the resistance wire in the circuit has resistivity, 1.4 10 to the power minus 6. The cross-section area of the wire is 0.25. Determine the length of the wire. R is equal to rho L over A. Then L is equal to R over L. R, resistance, you have calculated, 1.8. Area, look at this, it's in millimeter square. We have to convert this in meter. So we will divide it 1,000 and 1,000. Mean it becomes 10 to the power minus 6 and divided by this resistivity rho, 1.4 10 to the power minus 6. After calculation, you will get this 0.32. Next, the circuit shows in the figure 6.1. Okay, look at the circuit. Very simple circuit. Is modified by replacing the original resistance wire with a second resistance wire. The second wire has a greater diameter than original. There are no other difference between the second wire and the original wire. So, second wire greater diameter. Area is equal to pi by 4 diameter square. When diameter increases, area increases. And the resistance inversely proportional to area. When area is large, resistance is small. And according to the formula, power is equal to V square over R. This V is constant. The voltage, EMF supplied by the battery is same. It means power is inversely proportional to R. When R decreases, it means the power increases. Next. Now, two batteries are connected. The circuit shown in the figure is modified by connecting a second battery up in the 8-volt negligible internal resistance in parallel with the original battery and a regional resistance wire as shown by reference to the current in the resistance wire. Stated and explained whether the addition of the second battery caused the power and the original resistance wire to decrease and increase or to stay same. Look, in parallel, the voltage is same. So it says EMF supplied to the wire will be same. Same resistance, same length, so same current. So when in parallel, the EMF supply, the potential difference supplied to the wire is same, resistance of the wire is same, current will be same. So power is equal to V square over R, or power is equal to I square R, and the power dissipated will be same. Because no effect on the EMF supplied to the wire, no effect on the resistance, no effect on the current, the same power. Next question. A nucleus of the sodium decays by emitting a positron particle. A different nucleus is formed by decay. State the name of another lepton that is produced by the decay. When positron is emitted, along with the positron, neutrino is emitted. And it happens when a proton is converted into neutron, mean one up quark of the proton is converted into down quark for the neutron. So look, this is neutron, this is any unknown element, this is positron, this is neutrino, and the question is nucleon number. So the nucleon number, look, this is 22. It remains same. But positron has +1 elementary charge. So this will be 10. This is a equation we have to compare. Here the total 11. So 10 plus 1, 11. So this is 10. But this mass number 0, 0, it means 22, 22. Next is the quark composition of the nucleon in the sodium-22 nucleus is changed during the decay. Describe the change in the to the quark composition. Definitely, proton is converted into neutron during beta decay. Proton has up and down. This neutron has up and 2 down. It means one of the up is converted into down. Next, baryon consists of the quarks. And do remember, baryon has 3 quarks of the same flavor. The charge of the baryon is -2e, where E is the elementary charge. Calculate the charge E of the quark. So look, the charge of the baryon is actually the sum of the charges of the quarks, and the quarks are of the same flavor, X, X, X. So the charge of the baryon is -2 elementary. And this becomes 3x. It means x is equal to -2 by 3e. So the charge is -2 by 3e. And state the possible flavor of this quark. Look, this is anti-up quark because the up is +2 by 3 elementary. So anti-up will be -2 by 3 elementary. So this is a paper.